أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Today we are going to talk about correlation and regression. What is correlation? What is regression? Its definition, scenarios, and the calculations and the formula which is used for calculating correlation and regression. First, what is correlation? Correlation is the relationship between two quantitative variables that is continuous variable. For example, salt and blood pressure. If you increase the dose of salt, that will automatically bring a change in the blood pressure of a person or of a patient. If you decrease the dose of a salt, that may decrease the blood pressure of a person. In correlation, the values are from -1 to +1. -1 and +1, the closer a value which comes in your hand after calculation, if it is closer to the +1 and -1, that will give you the strength of association. If it is closer to 0, that shows the weakness of correlation or relationship. And similarly, the minus symbol shows the direction of association, that is negative association, and the plus symbol indicates that is a positive correlation between the two quantitative variables. Now, let us explain in detail by showing the slides or the presentation that I have made. So I am going to share the presentation and you will better understand this concept. So these are the slides, the PPT, which I am going to explain. Correlation, finding the relationship between two quantitative variables without being able to infer causal relationships. This relationship should not be called a causal relationship. There are so many factors involved. For example, if you want to see an association between salt and blood pressure, there may be diet, maybe stress, maybe pollution. So many other factors are involved which may increase or decrease the blood pressure, which bring changes in blood pressure. So you cannot say that it is a causal relationship. That it is a relationship, but that is shouldn't be say a causal relation. A causal relationship exists when there is a single variable that brings about change in the dependent variable or response variable. That should be called, and the causal relationship can only be established in randomized control trial, in true experimental designs where there is a strict protocol and you have to control each and every confounding variable, and you will see the relationship of one-to-one variable between two variables, but there would be no other confounding or supporting variables that bring change in the response variable or the outcome variable. There are two variables. The independent variable, and the dependent variable. This is also called outcome variable or a response variable. So these are the three names for the variable which is not in the hand of researcher. This variable is in the hand of researcher, like for example, salt and blood pressure, salt and BP. So what do you do if you want to increase the dose of a salt? Blood pressure will automatically increase. If you want to decrease this, this may bring change and this may decrease the blood pressure. So this is a positive relationship between these two variables. Our direct relationship, when one increases, the other also increases. There may be a negative correlation or relationship between the two variables. For example, exercise and BP. Here, exercise is an independent variable and blood pressure is a dependent variable. If you change exercise, the number of hours you do exercise, if you increase the hours, that will automatically decrease the blood pressure. If you get a sedentary lifestyle and there is no exercise, that may increase the blood pressure. So there is a negative relationship between these two variables, and there is a positive relationship between these two variables. Salt, increasing the dose, increasing BP, a positive relationship, and exercise, when you increase, there is more vasodilation and there is a drop in the blood pressure. So there is a negative correlation or a negative relationship between these two variables. As I have already explained, this independent variable is in the hand of researcher. He or she can change, can manipulate this variable, and this variable, the outcome variable or the dependent variable or the response variable, it is not in the hand of researcher, and a change occur with a change in the independent variable. Now let's see the presentation, the slides. Correlation is a statistical technique used to determine the degree to which two variables are related. The degree, how much is the relationship between the two variables, and the nature of the relationship, what type of relationship exists between the two quantitative variables, whether it is a negative relationship or it is a positive relationship. Scatter diagram. It is a rectangular coordinate, two quantitative variables. One variable is called independent, as I have already explained, and the second is called dependent variable, which is, on the y-axis, and the dependent variable is always on the x-axis. Points are not joined, and it is not a frequency table. This is, the rectangular coordinate. This is y-axis, this is x-axis. The independent variable is on the x-axis and the values of the dependent variable is on the y-axis. And these dots shows the relationship, whether it is a positive relationship or there is a negative relationship between these two variables. This is an example. Weight is the independent variable and systolic blood pressure is the dependent variable. When the weight increases of a person, that will bring change in the blood pressure, and the blood pressure also increases. So there is a positive relationship. If we determine the correlation and the calculated value is with plus symbol, it means that there is a positive relationship between these two variables, these two quantitative variables. When weight increases, the systolic blood pressure also increases. And from this rectangular coordinate, you can guess the relationship between these two variables. This is the weight, which is the independent variable, and this is the systolic blood pressure, which is the dependent variable, outcome or response variable. And these dots shows whether there is a positive relation or negative. It shows a positive relationship. When one increases, the other also increases. And the points which are far more from majority of the points, for majority of the values, these values are then called the outliers. So this is a line drawn between these two quantitative variables, and this line shows that there is a positive relationship between these two variables. Scatter plots, the pattern of data is indicative of the type of the relationship between your two variables. Like for example, if you draw a line and it is like this shows a positive relationship between the two variables. And if you draw a line and it is like this, it shows a negative relationship between the two variables. And when a line is drawn either manually or through computer, and it is like this shows curvy relationship between, sometime curvy linear relationship between the independent and the dependent variable. One which is over here, it is decreases. The other also decreases, but a time comes when one increases, the other decreases. So that is a curvy relationship between the two variables. Now let's move ahead. So the pattern of data is indicative of the type of relationship between two variables, a positive relationship, a negative relationship, and there is no relationship. If you see the dots like this, if the dots, those are plotted, the values are plotted and it shows like this, it means there is no relationship. No relationship. You cannot draw a line like this. You cannot draw a line like this. You can draw a line like this. So there is no relationship between these two variables, the quantitative variable, the independent and the dependent variable. Positive relationship. So it shows a positive relationship as the one independent variable increases, the other also increases. So there is a positive relationship between these two variables. And it is a negative relationship, as you can see, the dots are like this. And when you draw a line, it would be from upward to downward, from here to here. So that will be a negative relationship. And an example is the reliability and age of a car. When the age of a car increases, the reliability decreases. It gets older with the passage of time, and the reliability, the people cannot rely that it will work further or it will run for many years. The people believe that as the age of a car get older, it may not be reliable as a new car, as the car with a early age. So that is a negative relationship between these two variables. And when you see a dot like this, there is no clear-cut line you can draw like this, like this, like this. You can draw a line like this, straight, this straight line, which shows no relationship between these two variables. Simple correlation coefficient, and this symbol is called as rho. It is not P, it is rho. And this is for the population. Between the two pairs, the pairs of variables, between the two variables, a relationship in the population, all the possible pairs in the population. So we can denote it with rho. And if you take a sample, we can denote it with R. It is also called Pearson correlation or product moment correlation coefficient. It measures the nature and strength between the two variables of the quantitative type. Example, sometimes two continuous variables are measured in the same person, for example, height and weight, or in two groups, for example, comparison of tallness in parents with tallness of children. It looks for strength of association. If two quantities X and Y tend to change with each other, they are said to be correlated. It means that when there is a change in X and if there is a change in Y, then only you can say that these two variables are correlated. There is a correlation between those two quantitative variables. The sign of rho denotes the nature of association. while the value of rho denotes the strength of association. So, as I have already discussed, the values of rho ranges from -1 to +1. The closer the value to +1 and -1, the more stronger would be the relationship between the two variables, and the closer it to 0, the more weaker would be the relationship between the two variables. So nature of association means negative or positive association, and value of rho means strength of association. You can see on this slide, the value of rho ranges between -1 and +1. The value of rho denotes the strength of the association as illustrated by the following diagram. Plus, if it is closer to 0, plus 0.25, so there is a weak relationship on both the sides. If it is in minus or if it is in plus, in both the side, it shows a weak correlation. And if it is between 0.25, 0.75, it shows an intermediate relationship. And if it is closer to 1, a strong relationship. And if it is equal to +1 or -1, this shows a perfect correlation between the two variables. If rho is equal to 0, this means no association or correlation between the two variables. If 0 is less than rho is less than 0.25, the weak correlation. If 0.25 less than or equal to rho and rho is less than 0.7, intermediate correlation. And between 0.75 and between 1, if the values of rho fall, this shows a strong correlation between the two variables. And if it is exactly 1, this shows a perfect correlation between the two variables. How to compute the simple correlation coefficient R? The simple correlation coefficient R is, I have already said, that rho is for population, rho, and R is for sample. So most of the time, whenever we conduct a research and we want to see an association between the two quantitative variables, we take a sample. So we will use R rather than rho. But here the formula is for the population. It is not for the sample. When you put R, when you replace rho with R, then it becomes a sample formula. It is called Pearson method. Rho is equal to sigma xy minus sigma x sigma upon n, sigma x square minus sigma x whole square upon n, multiply by sigma y square minus sigma y whole square upon n. These two variables of the quantitative type, one variable age is called the independent and denoted as x variable, and the other weight is called the dependent and denoted as y variable. To find the relationship between age and weight, compute the simple correlation coefficient using the following formula. This is the formula which you have to remember. And on the day of examination, you are not allowed to take a paper on which you have written all the formula. It is not allowed. Sometimes it is allowed, but most of the time the examiners do not allow these formula on the paper to be used for calculation during the exams. So this is age and weight, and we want to determine whether there is a correlation between these two variables or not. And if there is a correlation, whether a positive correlation exists or a negative correlation exists. And if the correlation exists, whether it is weak correlation, intermediate, strong correlation, or perfect correlation. So now let's calculate the correlation between these two variables. One variable, which is age, 1, 2, 3, and number 2, that is weight, 2, 4, and 6. Now to calculate, we have the formula sigma xy minus sigma x sigma y divided by n divided by sigma x square minus sigma x whole square divided by n into sigma y square minus sigma y whole square divided by n. And this is under the root. You have to take square root. Now looking at the formula, we have to calculate all these values. Sigma is the summation, xy is the multiplication of the corresponding values, sigma x is the summation of all the values of x, sigma y is the summation of all the values of y, and this is the pair sample size, pair sample. Pair sample means you cannot calculate 1, 2, 3, 4, 5, 6, but this is taken as pair. For example, 1 pair, 2, and a third pair. So the sample size here would be 3 rather than 6. You have to take number of pairs rather than individual values. And sigma x square means you have to take square of all the values of x, and then you have to add up. And again, you have to sum the x values and then take square and divide it by n. And over here, you have to square all the values of y, then summation of all those values. And here, you have to sum all the values of y and then take the square divided by n. And these two are multiplied and then square root is taken. So over here, we can add up sigma x is equal to 1 or 1, 3, 3, 6, and sigma y is equal to 12. And here we have sigma, we have xy means you have to multiply x and y corresponding values. 2 1s are 2, 4 2s are 8, 6 3s are 18. When you add up these become 2 or 8, 10, and 18, 28. So you have already done with it. Sigma xy, 28, sigma x, sigma y is sigma x, and this is sigma y, and you have to multiply these, and your sample size is 3. Let's move ahead for x square. X squares, you have to take square of all the values of x. 1 square 1, 2 square 4, 3 square 9, and then you have to add up, and that will become how much? Say how much? 9, 4, 13, and 14. And again, you have to take square of all the values of y. So taking square of 2, that becomes 4. Taking square of 4, that becomes 16. Taking squares of 6, that becomes 36. And when you add up, that becomes sigma y square. And that is equal to 4 and 16, 20, and 36, that becomes 56. Now putting the values in this formula, we get sigma xy 28 minus sigma x, sigma y, sigma x is 6, sigma y is 12, and it is divided by 3. Again, sigma x square is 14 minus sigma x whole square. Sigma x is your 6 divided by 3, and again multiply by sigma y square, which is 56, minus sigma y whole square, which is 12 whole square divided by n, and this is under the root, and that becomes 28 minus 3 1s are 3, 3 2s are 6, so that becomes 12 2s are 24, and 14 minus 36 divided by 3, into 56 minus 144 divided by 3, and this is under the root. Now let's take it further. 28 minus 24 is 4, and 14, 12, and 14 minus 12 is equal to 2 into 3 ones are 3, 3 fours are 12, 3 eights are 24, which is 48. 56 minus 48 is equal to 8. And it becomes 4, and this is under the root. If you take square root of 2 8s are 16, that becomes 4. When you divide 4 by 4, that becomes 1. So R over here is equal to plus 1, which is a perfect positive relationship. A perfect positive relationship was found between these two quantitative variables. Let's see on the slide. This has already been solved, and let's see on the slide. These are the calculated value x, y, x square, and y square. And these are the summation sigma x, sigma y. Sigma x, y, sigma x square, sigma y square. And this is the formula. Rho, this is for population. You can put R over here for sample, pair of samples, sample pairs. So that becomes plus 1. The rho is equal to plus 1. That is perfect correlation between these two. Now you can find the correlation between these two, age and weight, with the number of values increases, the sample size gets larger. You can also do it by calculating x, y, x square, and y square, and then summation of all the values, and putting in the formula that will give you 0.759, which is a strong relationship, which shows a positive, strong relationship between these two variables. Strong positive correlation. Comparison of age of the car and price of the cars. This is the age in years, and these are the price of the car in rupees. So age 1 year, 6 year, 3 years, 4 year, 3 years, and 2 years, and these are the prices. For example, 12 lakhs, 8 lakhs, 12 lakhs, 10 lakhs, 11 lakhs, and 13 lakhs. So these are the different prices being given against the age. And these are the calculated value xy, sigma x and sigma y square, and it becomes minus 0.91, means there is a strong negative correlation between these two variables. When one gets larger, the other decreases. For example, when the age increases of the car, it will automatically put it down in the price. So the price will decrease. A regression analysis. And what is regression now? When the two quantitative variables are correlated, means there is an association or a correlation between the two variables, you can go for regression analysis as well. So regression will give you the best fit line, how to draw the best fit line, and moreover, it will also give you the probability of predicting or the prediction of a dependent variable when you know the independent variable. For example, if you know the age of a person, you can predict the weight of that person. Now let's move ahead. Techniques concerned with predicting some variable by knowing others. The process of predicting variable y using variable x tells you how values y changes is a function of the changes in values of x. Correlation and regression. Correlation describes the strength of a linear relationship between two variables. Linear means straight line, and regression tells us how to draw the straight line described by the correlation. So this is the best fit line, and this is also called regression line, and this is a regression analysis. So it calculates the best fit line for a certain set of data. The regression line makes the sum of the squares of the residuals smaller than for any other line, and the residuals are these are the, when one value changes, the other also changes. So a difference between the change in dependent and the response variable is called a residual. A regression equation describes the regression line mathematically, intercept when the x and y cut each other. That is called intercept, and the slope, when one variable change, there is a change in the other variable, it makes a slope. It goes up and there is a slope. This slope is called slope, and the line where which you draw between these two variables, the best fit line, from where does it start? That is called an intercept of y. So this is another diagrammatic explanation. Y hat, this is called y hat, which is equal to a plus bx. Y hat means the response variable. When there is a change in the independent variable, it predicts the response variable, the y hat, which is equal to a plus b, where a is the intercept, this is called the intercept, and b is the slope. When one changes, the other changes, and it gets it moves up, so it makes a slope, and this is denoted by b. That is a change in y. When it increases, there would be a change in the response variable in y. Change in x will bring a change in y, and there will be a slope, which is denoted by b. And there is a formula for y hat, a plus b x, and how to determine a, that is intercept, and how to determine b, the slope. There is a separate formula. A is equal to y mean minus bx mean. Mean of the x, mean of the y, or multiply by b. And how to determine b, how to calculate b? That is equal to sigma xy minus sigma x sigma y upon n, divided by sigma x square minus sigma x whole square upon n. When you remove the variable y in the formula of correlation, here you put, if you determine correlation, there is y square minus y whole square upon n. If you delete that and you do not take the square root of this one, and this is the same for both correlation and the b calculation, which is the slope. So these both are the same. It is easy to remember. If you remember the formula for correlation, you can easily remember the formula for the slope for the b. So here we have two variables, the age and weight. And first you have to determine the correlation between these two. Or if you do not want to, you can directly go for regression. So sigma x and x square, as I have already discussed, that a is equal to y bar minus bx bar, and b is equal to sigma xy minus sigma x sigma y divided by n, which is divided by sigma x square minus sigma x upon n, sigma x whole square. This is the formula for b. So you have to calculate, you have to determine y bar, x bar, and then b, like this: sigma xy, sigma x sigma y, and sigma x square. So you have to calculate all these for calculating regression. So these are the calculation: x square, xy, and this is sigma x and sigma y. Putting all these in the formula in b, sigma x sigma y, that will give you a value of 2. So b over here, the slope is the slope b is equal to 2. And now a, y bar minus 2 into x bar. So you can calculate the x bar and y bar. For example, x is equal to 1, 2, and 3. and the x bar will be equal to 6 upon 3, that will become 2, and the y bar will be equal to, if y is equal to 2, 4 and 6, then 6, 4, 10 and 12 divided by 3 is equal to 4. So putting these in the formula of A, which is the intercept of regression, you can get y bar is equal to 4 and x bar is equal to 2, putting these in the formula, which is equal to 0. So intercept is equal to 0. And now putting a regression equation, you have y hat. Y hat mean y is the dependent variable that you have to determine on the basis of x. If you are given the value of x, a plus b into x. So if you have calculated a, you have calculated b, and if you have a certain value of x, you can determine or predict this y hat or change in the y variable, response variable, outcome variable, or dependent variable. Y hat on the basis of 0 plus 2x. Now we can predict weight if we know the age. Suppose the age is 4 years, then this equation becomes, you can put 4, you can replace x with 4, and that will become 8. So the predicted weight becomes 8 kg. So if you know the value of x, you can predict the value of y, which is the response variable. Exercise, a sample of 6 persons was selected with the value of their age variable and their weight is demonstrated in the following table. Find the regression equation and what is the predicted weight when age is 8.5 years and what is the predicted weight when age is 7.5 years. Now these are the values. First you have to calculate x, y and x square. Putting in the formula, you will get y hat is equal to a plus b x, where a is 4.675 and b is 0.96. Now you can put the x value to predict the y value, which is the response variable. Now we have been given that if the age is 8.5 years, what will be the weight of that person? So over here, the x is 8.5. What will be the predicted value? Or the when the age is 8.5 years, what will be the predicted weight? So it will become 12.50 kg. And again, the predicted weight when age is 7.5 years, that becomes 11.58 kg. This is another example. You can do it yourselves, but let's looking at the slides. I'll show the slides so that you can better understand, and you can do practice on your own as well. So find the correlation between age and blood pressure using simple correlation coefficient and comment. Find the regression equation. What is the predicted blood pressure for a man aging 25 years? So these are the value. First you have to calculate the correlation. The R sigma xy minus sigma x sigma y upon n, sigma x square minus sigma x whole square upon n into sigma y square minus sigma y whole square upon n. So you have to calculate all the values, x square, y, xy, and then you have to put, this is the B, which is 0.45, and the A is equal to 112, y is equal to A plus BX. So for age 25, the predicted pressure is BP 112.8 plus you have to put the age over here in this formula. You already know the value of A and the value of B. So that will become 123.5 mm of Hg. And that is the end of correlation and regression. If you have any question, you can comment. You can give me your feedback, and I may improve myself. If you are agree, you can like, you can share with other colleagues so that a maximum number of learners be benefited of these lectures or